Welcome back to the lecture series of linear algebra part 3. So we will start with the one new subtopic, that is this is lecture series part 3rd, linear algebra. Linear algebra part 3. So we will start with the new topic, that is shortcut to find determinant and inverse of a matrix. We will see shortcuts to find determinants and inverse of a matrix. So the topic is shortcut to find the determinants and inverse of a matrix. Inverse of matrix. Okay, now we will consider one matrix. Suppose this is one matrix. Suppose A is one matrix. It is 3 cross 3 matrix, means 3 row 3 column, and the elements are 1 3 4 2 1 1 2 1 2 and 1 -1 and 3. Now we want shortcut to find the determinant of the matrix. So what we will do, we will write all values, all the elements here, like 1 3 4 2 1 2 1 -1 and 3. Now we will write another 2 column, means these 2 column we will write again. These 2 column we will write again. So it will 1 2 1 and this column we will write again. So this is 3 1 and -1. Now we will stop here. Now what we will do, we will multiply in this way. So we will multiply this arrow, whatever elements falling on for whatever arrow element fall on this arrow, we will multiply to them. So similarly again this arrow and this arrow. Okay, so we will multiply it here. So on this arrow we are getting 1 1 and 3. So we will multiply 1 into 1 into 3. Okay, on this arrow we are getting 3 2 1. So we will write plus sign here, and we will multiply all these 3 values, 3 into 2 into 1. Now again we will write plus sign, and we will multiply all elements falling on this arrow. So we are all elements are 4 3 2 and -1. So 4 into 4 into 2 into -1. Okay, so this arrow, all these 3 arrow get multiplied. So close the bracket. Now just write minus sign and multiply this upper arrow like that. So it will start from here this arrow. So what elements falling on this arrow? This element, this element, and this element. So just multiply once again 1 into 4, then plus sign, then multiply this elements on this arrow. So this -1, 2 and 1. So -1 into 2 into 1, close the bracket, then plus sign again. Then similarly you draw arrow pointing upward. So this is the arrow pointing upward. So elements falling 3, 2, 3. This element 3, 2, 3. So just multiply it. 3 into 2 into 3, 3 into 2 into 3, and just close the bracket. Okay, you got the logic how I am calculating. Okay, so in this way you can calculate the determinant in easy way. So you are getting 3 after solution. You are getting 3 plus 6 minus 8, then minus sign 4 minus 2 plus 18. After solution you are getting minus 19. So this is the determinant. This is the determinant value. This is the determinant of A. Determinant of A. So this is the solution. This is the solution. This is the solution to get the determinant. So this is the shortcut to get the determinant value. Get determinant value of any matrices. Now we will see how to calculate inverse. How to calculate inverse by shortcut method. Now shortcut to calculate transverse. Shortcut for transverse. Again we will take the same matrices, same matrix, that is matrix A, whose elements were 1, 3, 4. It is 3 cross 3 matrix, means 3 row 3 column. So okay, this is the matrix. Now we will apply one shortcut method to get the inverse of A. So what we will do, we will take these 4 elements and consider it as A. Okay, clear? And we will take these 4 elements and we consider it as B. Now we will take these 4 elements, consider it as C, whereas we will take these 4 elements and consider as D. Okay, it will clear to you what I am doing. So if you want to get the inverse of a, then what you will do, you will just write 1 divided by determinant of a and take this matrix and you write this, convert it into 4 quadrant like this, and you write D here, you write C here, you write A here, and you write B here. You just shift A down side, D upper side, B this side, and C this upper side. Okay, just reshift this and write. So I will write all these values here. Determinant of this A matrix already we calculated. We got this minus 19. Just I wrote the value of minus 9 determinant of A, and I will write all the values of A. So what D we have considered all, just write all 4 values, 4 elements, 1 2 minus 1 3. So all these 4 values are D. Now just write C values. So all these 4 values are C. So 2 1 1 minus 1. Okay, now similarly B is 3 4 1 2. These are B. So I just wrote B value, and A. So these all 4 values are A. So 1 3 2 1 1 3 2 1. Okay, I just wrote. Now what I will do here, I will just consider, you take like this. I will consider all these 4 elements and I will take determinant of these 4 elements. So how determinant I will get? So I will multiply 3 into 1 minus 1 into 2. In this way we will get determinant of these 4 elements. Okay, so how I will get? I multiplied these 3 to 1 minus 1 into 2. So after solving I will get 5. So just write 5 here. Now consider these 4 values. And calculate the determinant of these 4 values. So how you will get determinant of these 4 values? You just multiply 2 into 1, this 2 into 1 minus this 3 into 2. So 3 into 2, you will get minus 4. So write minus 4 here in this column. Okay, now consider these 4 elements and get the determinant of it. So you will get the determinant 2 into minus 1 bracket close, minus of this 2 into minus 1 minus sign bracket close 1 into 1. You will get the determinant of these 4 elements. So you will get minus 3. So just write minus 3 here. Okay, you understood the logic how I am calculating. Okay, now similar fashion you take these 4 values. Okay, these 4 values and calculate the determinant. Calculate the determinant of it. Minus 1 minus 1 3 3 4, and calculate the determinant of these four values and just write here in this second column. So you will get minus 13. Okay, now you take these four values and calculate the determinant. So these four values are 3 1 3 1 4 1, and you calculate the determinant and just write here. So you will get 3 minus 1, so you will get minus 1 here, so write minus 1 here. Now you take these four values and take the determinant. So these four values are 1 minus 1 1 3, and you calculate the determinant and you write in here this value. Okay, now similarly you take these four values, okay, and calculate the determinant of these four values and write here in third column. So you will get 2. Now you take these four values and calculate the determinant and you will get 6. You take these four values, calculate the determinant and write here, you will get minus 5. Okay, and just write this value, this determinant of a, so minus 19. Now this is the value, this is the a inverse. This is the shortcut how you calculate the inverse of a matrix, 3 cross 3 matrix. Okay, clear to you? Now we will start another. Now we will see some properties of determinant, inverse, adjacent and transpose. So we will see some properties. So we will see some properties. So properties of determinant, inverse, adjacent and transpose. These four topics properties we will see. Okay, so one by one we will see the properties. So first property is, if you take the matrix AB transpose, whole transpose, so you will get B transpose into A transpose. This is the first property. Second property is, if you take A transpose to the transpose, you will take A transpose, again you apply transpose to A transpose, so you will get A. Okay, third property is, if you take A inverse and apply transpose to this, then you will get A transpose inverse. Okay, fourth property is, AB inverse, AB matrix inverse, if you applying, then you will get B inverse multiplied with A inverse. This is the fourth property. And fifth property is, if you take determinant of A inverse, then you will get 1 by determinant of A. Okay, now sixth property is, if you take A inverse to the whole inverse, then you will get A. This is sixth property. Now seventh property is important. Second property is important. If you apply adjoint of a, if you apply adjoint of a and you take determinant of adjoint of a, then you will get determinant of a power n minus 1. Okay, similarly, if you take adjoint of a, then you will get det of a n minus 1 whole square. Two times adjoint is coming, so that's why whole square. Similarly, if you take adjoint of a dot of adjoint a k times, you applying adjoint k times, you taking adjoint k times, then you will get det a power n minus 1, det a power n minus 1 and to the power k, because adjoint is coming k times, so that's why power k. So these are the sum properties. Okay, these are the sum properties. Now we will see determinant of matrix n cross n. Now we will see determinant of matrix of a matrix a cross n, a n cross n. Okay, so we'll calculate the determinant of a cross n matrix. So determinant of a will be equal to, we can write determinant of a in this fashion also, det of a, it will be sum of product of any row or column elements corresponding to cofactor. It will be sum of product of any row or column, any row or columns elements and corresponding cofactor. Okay, this is the case how you can calculate the determinant of a. Now you take example, you take matrix A whose elements are 1 2 4, 2 1 3, 1 minus 1 4. Now you want to get the determinant of this matrix, so you can apply determinant of a in this fashion, determinant of all these values. So it will be 1 2 4, 2 1 3, 1 minus 1 4. Okay, so what I will do here, I will expand from first row. So determinant of a from this element, from here I will start to expand. So I will write this element 1 here, and I will write minus 1. So this element is first row, first column, so it is in first row and first column. So I value, any element we can denote a11 aij, any element we can denote aij. I is row j is column. So here I value is 1 and j value is also 1, so it is in first row and first column. So minus 1 to the power number of row plus number of column, so it is in first row and first column. So 1 plus 1 minus 1 to the power, and just take hide this row and this column. Okay, so hide this row and this column and just take remaining values, these values. So take the determinant of remaining value 1 3 sorry so just write the all values 1 3 minus 1 4. Okay, now write plus and you take this value 2 and write 2 here, write minus 1 to the power number of row and number of column. So 2, this element is in first row, this element is in first row and second column. So I value is 1, number of row is 1 and number of column it is in second column. So 2, 1 is row first row, it is in first row and it is in second column. Okay, so first row plus second column, and you hide this row and this column and write remaining values. So remaining values is this one and this one, so just write remaining value. Okay, so remaining value is 2 1 3 4. Okay, similarly now you write this element 4 and take cofactor minus 1. So this element is in first row third column, so 1 minus 1 power is first row plus third column, and take hide this row this column and write remaining value. So these are the remaining values, remaining elements. So 2 1 1 minus 1 and expand it, you will get the determinant. So after expansion I am writing here, after expansion you will get 1 minus 1 1 plus 1 2 minus 1 ka square, minus 1 square is plus 1, so this is plus 1, and this determinant you can calculate 1 into 4 1 into 4 minus 1 into minus 3, so you can write 1 into 4 minus 1 into 3. This is the first up to here I have calculated. Now here you can write 2 this 2 and minus 1 cube, minus 1 cube means minus 1, so it is minus 1, and you can expand this determinant, you can expand this determinant, so it will be 2 into 4, it will be 2 into 4 minus 1 into 3, so it will be 1 into 3. Just close the value. I have calculated up to this. Now you write this value 4 and minus 1 1 plus 3 means 4, minus 1 to the power 4, 4 is odd even number, so minus 1 power even is plus 1, and you expand this determinant 2 into minus 1, so this will be 2 into minus 1 फिर minus 1 into 1 into 1. Now you solve this, you will get the determinant of A. So after solving you will get minus 15. So this is the determinant of A. Okay, this is the process how we calculate determinant of any in matrix. Okay, now we'll see some properties again of determinant. So we will see some properties of determinants. So first property, if you calculate the determinant of A, it will be equal to determinant of A transpose. Okay, this is the first property. Second property is, if matrix has 0 row or 0 column, then the determinant will be 0 of this matrix. If any matrix has 0 row has 0 row has 0 row or 0 column, then determinant of that matrix will be 0. Suppose, consider for example matrix A, which is 1 2 0 0. So in this matrix, this row is 0 row. So in this matrix, one row is 0. Okay, so determinant of this matrix will be 0. Okay, because it is having 0 row. Okay, or if any matrix having 0 column, okay, then again it will have 0 determinant. So this is the property. Now third property is, if any two row or column of a matrix are equal or proportional, okay, equal or proportional, then again determinant of that matrix will be 0. See here, if two row or column of a matrix are equal or proportional, then determinant of that matrix will be equal to 0. Okay, example, see here, consider an matrix 2 cross 2 matrix, means 2 row 2 column, this 1 2 and 2 4. This is one matrix, for example. So you can notice that this column having element 1 and 2. If you multiply this column with 2, then you will get same column. This column means it is 1 into 2 is 2 and 2 into 2 is 4. So this column is multiple of this column, means this column is proportional. So these two columns are proportional, that's why determinant of this matrix will be 0. Okay, or you see this row is, if you multiply this row with 2, then you will get this column, this row, means these two rows also proportional to each other. Okay, if any row or any column of a matrix are proportional or equal, then determinant of that matrix is 0. This is the third property. Now talking about the fourth property, so if two rows or column of a matrix are interchanged, if you interchange any column or any row, then we multiply determinant of that matrix with -1. Okay, see here, if two rows or column of the matrix are interchanged, then their determinant is to be multiplied with -1. Is to be multiplied with -1. Okay, so for example, this is the matrix. Suppose 1 4 3 15, and its determinant is 3. Now what I am doing, I am just interchanging the rows. So I will make second row as first row. Here I am changing this row, this second row, and making it first row here, and this first row I am interchanging it with second row. So I've just interchanged the rows. Then I got different matrix, that is B matrix, and if you calculate the determinant, it will be same as determinant of A, but you have to multiply with -1, that is with -1 sign, that is -3. So this is the property. Now talking about the fifth property. If the determinant of diagonal matrix or lower triangular matrix or upper triangular matrix, if a matrix is diagonal matrix or lower triangular matrix or upper triangular matrix, then the determinant of that matrix will be just the product of diagonal element. You just multiply the diagonal element, you will get the determinant of that matrix. So see here, the determinant of diagonal matrix or lower triangular matrix, lower triangular matrix or upper triangular matrix, then it is just product of diagonal elements. It is just product of diagonal elements only. Okay, this is the fifth property. Now sixth property is, if all the elements of a row or column of matrix are a scalar multiple of k, then determinant will be just multiply with that k, a scalar value. Okay, so see here, if all elements of a row or column of a matrix are a scalar multiple of k, then the determinant of A will be multiple of a scalar value k only. Okay, this is the property. Example, see here one example. If determinant of 2 4, if determinant of this matrix will be equal to just take the multiple, it is multiple of 2, so just take 2 out of it, so it is 1 2, and you can write 3 4, you can write like this. Okay, I took just 2 out of it and wrote here. Okay, this is the property. Now talking about the seventh property, if all the elements of matrix are multiplied by scalar value k, then we can write determinant of k a is equals to k to the power n into determinant of a. See here, if all elements of the matrix are multiplied by a scalar k, then determinant of k a will be equal to k to the power n determinant of a. You can write like this. For example, you see determinant of a is 2 4 6 10. Okay, now you take you calculate the determinant of a, you will write date of 2 4 6 10. Okay, so what you can do, you take 2 out of it and you write 1 into 2. If you multiply these 2 1 and 2, you will get 2 4, this row. So I took 2 out of this row column and I took again 2 into 2 from this row, so I wrote 3 5. If you multiply these 2 with this row, you will get 6 10. So I took this in this way. So if you calculate 2 into 2, this 2 into 2 will be 4, and determinant of 1 into 5 minus 3 into 2, so 3 into 2, if you calculate, you will get minus 4. Okay, this is the seventh property. Now we'll see eighth property. Eighth property tells you like if every element elements of a row, or if a row or column is multiplied by a scalar quantity, and added to another row. If you multiply any row or column and add to it another row or column, then determinant remains same. There will be no change in determinant. So another row or column then the determinant remains same. Determinant remain same. Okay, for example, you take row j row and you multiply j row row 1 row I row with alpha, some scalar value, and add it to j row. Okay, and similarly, if you what you do, you just multiply this alpha to c1 column and add it to jth row. Okay, then in this, if you operate this in a matrix, then determinant will remain same. So suppose, see one example here. Suppose this is one matrix whose element is 1 3 and 2 8. Okay, and what you do, you just calculate the determinant. You know how you calculate 1 into 8 minus 2 into 3, so you will get determinant 2. Now what you do, you apply this operation. You multiply 3, that is 3 is scalar value, to row 1 and add it to row 2. Okay, so after operating this, you will get multiply this row 1 with 3, so this element will be 3 and this element will be 9, and just add it to second row, so 3 plus 2, it will be 5, and this 3 into 3, 9 plus 8, what it will be, 17, and first row will be same, and you calculate the determinant, you will get same 2. So see, these 2 and these 2 are equal, means this operation does not affect the determinant value. See another example. You multiply scalar value 2 to column 1 and add it to second column. See, I am multiplying 2 to this column, so it will be 2 into 1 plus, and adding to second column, so this is the second column, so 2 into 1, 2 plus 3, 5, so it will be 5, and this 2 into 2, 4 plus 4, 8, 12, so this column will be 12 and first column will be same, and just you calculate the determinant, you will get again 2. Okay, so this tells you that this operations does not affect the determinant value. Now ninth property is, if you calculate determinant of AB matrix, then it will be equal to multiple of determinant of A to the determinant of B. This is the ninth property. And 10th property, if you take the determinant of A power k, you can write it as determinant of A to the power k. Okay, so these are the some important properties of determinants. In next lecture we will solve some example problems. Okay, so see you in the next lecture. Thank you.